Welcome. I'm Dr. Jeff Borenstein. Everyone is touched by psychiatric conditions, either themselves or a loved one. Do not suffer in silence. With help, there is hope. Today, on Healthy Minds,
it was an unknown nicotinic receptor, and a lot of people doubted that it even existed. We've missed the actual development of the neuropathology, the brain problems that give rise to schizophrenia.
That's today on Healthy Minds. Healthy Minds is brought to you in part by the American Psychiatric Association Foundation, the Graham Beck Foundation, the New York State Psychiatric Association, and the New York State Office of Mental Health. One out of 100 people has schizophrenia. Imagine if we had a way to decrease the risk of developing schizophrenia. Today, we speak with Dr. Robert Friedman, a leading brain researcher who's working to develop new treatments and methods of prevention for schizophrenia and other psychiatric conditions. Bob, thank you for joining us today.
Jeff, it's a pleasure.
I want to start off by asking you about your interest in schizophrenia. How did you develop that interest?
I began reading about it in college, and when I learned that schizophrenia is an inner reality where the person who suffers from it has lost contact with the outside world, I thought that it was the most uniquely human illness I could think of, and I wanted to learn more about it.
And tell us a little bit about your progression of learning more and then becoming involved in research.
I began becoming interested in the nervous system itself, and I spent a great deal of time at medical school and at the NIH studying how single nerve cells work. And I began to realize that the drugs we use currently to treat schizophrenia change the way that nerve cells react to the world around them. Just like the patients have trouble regulating how they react to the world around them. And I became interested in what the problem actually was in real nervous systems of people with schizophrenia. Now, laboratory animals where we study single neurons don't get schizophrenia. It's a uniquely human illness. And so I began to learn how to apply our techniques to study how the brain reacts to stimuli around it by studying the EEG waves of actual human patients.
So you were able to combine a few approaches, looking at living human beings, looking at laboratory animals and other models of schizophrenia to develop a better understanding of what is going on.
Exactly. Schizophrenia is a uniquely human illness, but the human brain is one organ which we normally can't touch.
Tell me a little bit about what you found and how you were able to translate that into potential methods of treatment and prevention.
We came to understand first that the brain of someone who has schizophrenia is actually hyperreactive to the world around it. And so it's bombarded with sounds and sights and smells that normally most of us are able to screen out. Our brains have limited capacity to understand the world around us, and so we make sure to funnel to our brains only what's important.
So walking down the street, if there's noises over there and cars there and crowds to your left or right, you're able to focus on the direction you're going and the noises and signals that you need to be focused on.
Focus is the key word. People with schizophrenia can't do that focusing, and so they end up responding to everything, and as a result, they get more information in than they normally can process. And so delusions, hallucinations flow from this problem in how the brain works. We wanted to understand why the problem happened to begin with, and we began to deconstruct all of the circuits. And we realized that the weak point in the circuit was a particular synapse or connection between two nerve cells that uses a neurotransmitter called acetylcholine and activates a receptor called the nicotinic receptor. Now, it was an unknown nicotinic receptor, and a lot of people doubted that it even existed. And so I did what any right-thinking neurobiologist would do. I got on the plane immediately and flew to Paris, because in Paris is the dean of all nicotinic receptors, Jean-Pierre Changeux. And I said, "Professor Changeux, what do you think?" And he said, "I can't be sure, but it's probably an artifact." And I said, "What do I do?" He said, "Go home and do more experiments. I'll call you." 6 months later, he called me. He said, "We've cloned your receptor. It's real. There's a gene that makes it, and that gene turns out to be one of the many genes that is affected in schizophrenia. In some patients, one copy of it is entirely missing."
I just want to interrupt for a second to point out the importance of collaboration in research. These discoveries don't happen by oneself, they happen in collaboration with other scientists, and that's a great example that you just shared.
Exactly. Scientists worldwide study these receptors, they study schizophrenia. We rely on everyone's knowledge to do the best we can for patients.
So now you have the receptor. What's the next step?
We thought the best thing to do would be to try to find a drug that worked on that receptor, because our current drugs, except to some extent clozapine, do not. And we all know that as well as we do treating patients with schizophrenia, we all need to do a lot better. And so one way to do that is to find better medications. So we began to research drugs which would attack this receptor and somehow restore part of its function. And I went hat in hand to every drug company, and they all turned me down. Too risky, too new, too innovative. And then I was searching the web, and I found a man, William Camet, Florida, who had such a drug. He's a professor at the University of Florida. And I called him up and I said, "I think I have the illness that your drug is good for." And he said, "I'm glad to hear from you. I've been sitting by the phone for 10 years waiting for this phone call." And we got together, and the Food and Drug Administration and the federal agencies got together, and we did the first test in human beings. The test was successful. We published the results, and then every drug company had to have a program, because it turned out no drug company could take the risk, but no drug company could be left behind. And so we're now hopeful. There are several of these drugs in the last stage of testing by major pharmaceutical companies, that a drug very similar to ours will soon be available to patients.
And this is a medicine that has a different mechanism of action than the medicines that are currently available for people.
Right. And it can just be added to the currently available medicines. So we can take all the effects that the current medicines are capable of doing and add more. And particularly what we're adding is increased focus for the patients, so they can do the things that normal people do.
In many ways, that lack of focus, the apathy that sometimes occurs, is more difficult to treat and more troublesome for people than the hallucinations and the delusions.
Well, you have to treat both. And by taking both medications, our current medications plus one of these new ones, you would get both effects.
In addition to improving treatment for people who have schizophrenia, you've also been working on developing methods of prevention. And I'd like you to speak about that.
I was thinking one morning that we had actually missed the boat. That if we thought about the fact that this receptor is already miscoded at the genetic stage, and we're waiting until we have a patient with schizophrenia in his late 20s or her early 30s to begin this treatment, we've missed the actual development of the neuropathology, the brain problems that give rise to schizophrenia. And I began to think that we were treating the illness at the wrong phase, after it was already fulminant, when we should be treating it is when it's developing. And so we immediately switched a great deal of our efforts into understanding what this receptor does during development. And of course, other people had been studying it as well, and what we discovered is what they already knew and now has been reconfirmed, that the receptor and the gene are 10 times more active before birth than even in the newborn period. So the period of most activity of what we thought was an important element in the development of schizophrenia was not after birth, it was before birth. And that's where we should be intervening.
So taking steps that even before the baby's born can decrease the risk of developing this illness.
Right. There was one little problem that we began to notice, which was as important as this receptor is, and 10 times as much of it in the fetal brain as even in the newborn or adult brain, there was no acetylcholine coming up from other areas of the brain to activate it. So the receptor just seemed to be sitting there. And we knew that couldn't be true. So we looked to see if we could figure out what was activating the brain, this receptor. And it turned out it was choline itself, not acetylcholine. That would only happen after birth. But before birth, it was choline, and the choline was found in the mother's amniotic fluid. That's the fluid that surrounds the baby while it's still in the womb. That fluid is made by the mother, and it has enough choline within it to activate these receptors. So they're being activated by the fluid itself.
So this led you to come up with potential intervention to assist in the process.
The final thing we learned was that women are often deficient in choline. It's the one time in the human life cycle that you can be deficient in choline is when you're a pregnant woman. And the reason is that the baby's cell membranes, its muscles, its skin, its organs are all made out of choline. And so the mother needs enormous amounts of choline. And most of it comes from eating. It comes from eating foods that are high in animal protein. So meats, liver is very high, eggs, those are all things that mothers can eat to get choline. A lot of women can't eat enough, they can't get enough in their diet. A lot of women are very stressed, and when they're stressed during pregnancy, choline unfortunately is held in the mother's liver instead of released to the baby. And if a mother is infected, if she gets a cold, if she gets pneumonia, that will also cause her to sequester the choline in her own body and will also provoke a stress reaction against the fetus itself. So there are all kinds of reasons why mothers might need extra choline.
You've begun to look at what happens if you give a pregnant lady extra choline.
So we asked the FDA for permission to double the daily dose of choline for pregnant women in a clinical trial where half the women would get the double dose, so they would get 1 dose from eating and 1 dose which we would give them as capsules. And the other half of the women would also be encouraged to eat the same way. We didn't want babies who were choline deficient. So we sent an obstetrical nurse in several times a month to each mother to encourage her to eat everything she possibly could to get a diet rich in choline. So all the mothers got that instruction, but some in addition got a full extra day's supply of choline, and some got placebo. And it turns out that babies who had received the extra choline were much more likely to be able to do the focusing than the babies who did not receive the choline, the supplemental choline. And so the supplements were doing good as early as the first month after birth when we could first record the infants.
And you followed these children over time now for a couple of years.
That's correct. So time marches by, and the children are now reaching 4 years old. And at about 3.5 is the first time that parents can reliably rate what their child's behavior is like And in addition, the behavior they rate at 3.5 years old tends to be an enduring trait with the child throughout childhood and often for the rest of their lives. So essentially, by 3.5 years old, a child is beginning to show what its behavior is going to be like for the rest of its life.
At least thus far, in terms of the research, there appears to be an upside in terms of the results without any risk.
Exactly. After all, it's a natural nutrient.
And this is similar to the approach taken for many years with pregnant women in terms of other nutritional supplements.
Right. The model for us is folic acid. So folic acid is also something that a woman could easily get by diet, but she'd have to eat a lot of lettuce. But if she were willing to eat enough lettuce, she would not only get the normal dose of folic acid, but she would get a super dose of folic acid. But we know that it's cheaper and more effective simply to give women folic acid in a tablet. And so now all women take their prenatal vitamins and we intentionally overdose them with folic acid. Why do we do that? Because if we do that, the incidence of cleft palate, spina bifida, and some other very terrible neural developmental illnesses all are greatly diminished. We're hoping that choline will do the same thing for a range of mental illnesses.
So with regards to schizophrenia, where 1%, 1 out of 100 people, develop schizophrenia, the hope is that this early intervention can reduce that rate of schizophrenia.
That's what we hope. Now, unfortunately, the human life cycle for our patients is exactly the same as mine, and I'm not starting off as a newborn. So by the time these kids and other kids get to 25, 30, when we know what the true incidence of schizophrenia in that group is, I'm going to be rather elderly. So I'm hoping that this is a piece of research we can hand from one generation to the next, just as we hand our patients from one generation to the next. But if we can begin to think about how we can actually decrease the incidence of schizophrenia, and more important, give kids better brains, then I think we'll have done kids a service.
Well, I think that you were collaborating with younger colleagues, so you are working with the next generation, and also you're collaborating with other disciplines. What has been the response of colleagues, of lay people, and others as they've heard about this intervention?
Many colleagues have been quite excited by it. I would say Will Carpenter, the Dean of Schizophrenia Research in our country, was the first to take up the banner for it. And almost everyone who's expecting grandchildren comes by to find out what we're doing and get the recommendation for what's best to do.
For the intervention with choline for pregnant women, is that something that should be used for people who may be at a higher risk of their child developing schizophrenia, or is it something that could be recommended for all people?
A basic intervention like choline was actually designed from the beginning to be population-wide. You could say, as you did, should we only do women who have schizophrenia themselves? Now, we have tested them separately, and it does work in them and their babies, but we know that most cases of schizophrenia do not come from children of schizophrenic parents. Only about 10% of people with schizophrenia have a parent with schizophrenia. And so most of the cases are going to come from two parents who are entirely without mental illness. Therefore, just doing high-risk families doesn't really make sense. You could say, could we test for this nicotinic receptor? But it turns out that there are many, many different ways in which it can be abnormal in patients. And we don't actually yet know all the ways. And it would be very expensive and error-prone to try to find all the possible ways. And so it's cheaper and more effective just to treat with choline. Just again, as we do with folic acid. It's cheaper to give every woman folic acid so we don't miss anyone. It's also therefore more effective.
Given that there is no downside, that it's a natural nutrient that people are taking in anyway, and any excess just doesn't get used. Given no downside and the potential upside, it makes sense that everybody have it.
Exactly. If it were a high-risk treatment, that would be something else, but this was always designed to be a low-risk treatment.
In addition to potentially reducing the rate of schizophrenia, what other psychiatric conditions may this be helpful for?
One of the lessons of the Human Gene Project is that the idea that it would be one gene for one illness is simply not correct. Illnesses have multiple genes, and each gene has multiple illnesses. So the nicotinic receptor that we study, technically the alpha-7 nicotinic receptor, whose gene is on chromosome 15.
We'll have a quiz after the show.
Exactly. That gene is also responsible for some cases of autism, for bipolar disorder, for ADHD, schizophrenia, and severe developmental disorders. So just like folic acid is good for a range of neurodevelopmental disorders, potentially choline has effects beyond schizophrenia, which is, for example, a less common illness than ADHD. And so we don't actually know at this point how many illnesses or to what extent in each illness it's going to be effective, but we do know that at least 3.5 years old, the children have better social and cognitive function.
Is there any benefit for a person to take this as an adult, or for a child to take it, or is it only during pregnancy that there's a benefit?
The window is very short, and that's unfortunate because I think prudence would say we should wait until we know everything we possibly can about choline, and then one should take it. But the window is only the 2nd and 3rd trimester of pregnancy. And so there's only 6 months in which choline makes a difference. Choline has been studied in older people and in adults, and frankly, we're not choline deficient. And so there is no reason for anyone to take choline except perhaps a pregnant woman.
Your work is work that brings together very basic research from the lab to actual clinical interventions with living people. And I'd like you to speak a little bit about the process of research and how it works and where the hope is for the benefits of research.
So research knows no boundaries, and I think for me there's a double motivation. One is the brain itself is immensely fascinating. I'm also aware as a clinician that people with schizophrenia have problems that we can't help them solve at the moment. And I often feel very inadequate as a clinician because the tools at my disposal are not sufficient to cure schizophrenia. And so I have both motivations going on at all times. And sometimes the science has to run free and just discover whatever it's going to discover. And sometimes we have to say, wait a minute, how do these discoveries apply to human beings? And sometimes in talking to patients, they give us a clue to how their brains are malfunctioning. So we first began to realize that how nerve cells respond to their environment is crucial because patients were telling us that they were finding the stimuli around them overwhelming. And when we put those two together, then we had a glimmering of insight into what might be wrong and what parts of brain function to look at.
So you were able to combine the actual words and descriptions of people who have schizophrenia with some of the very basic findings in neuroscience, and then develop an approach and a new treatment that can result in prevention.
Exactly. But I can't do with a laboratory animal the very sensitive test that I can do with a human being, which is to say, Jeff, what are you thinking about? That tells me a lot about what your brain is like and how it's processing information. Much more, in many ways, that I could learn if I knew what every one of your nerve cells was doing.
Right. All those nerve cells come together to bring about the thoughts and emotions that we all experience.
That's right.
Bob, I want to thank you so much for the work that you've done, the research, the clinical work, your leadership in psychiatry, and thank you for joining us today.
Jeff, thanks for the opportunity.
The goal of brain research is to develop better treatment and ultimately cures and methods of prevention. As we heard today, we're approaching the day that the dream of prevention becomes a reality. Recent advances in research truly offer us hope. Until next time, I'm Dr. Jeff Borenstein. Goodbye. With help, there is hope. Healthy Minds is brought to you in part by the American Psychiatric Association Foundation, the Graham Beck Foundation, the New York State Psychiatric Association, and the New York State Office of Mental Health.